In this section, we're going to introduce details of IP address. As we explained previously, IPv4 address has 32 bits. These 32 bits are divided in two parts, network ID and the host ID. To represent IP address, we divide these 32 bits into 4 groups, with 8 bits for each group. Each 8 bits are represented as decimal numbers and separated by a dot. Therefore, usually we see an IPv4 address like this: 131.100a.122.204. Each number ranges from 0 to 255. IP address is classified in A, B, C, D, and E 5 groups, amongst which Class E is reserved and Class D is used for multicast address. Therefore, the IP address classes we usually say are Class A, B, and C. Class A address starts with 1 bit 0 on the left. The first 8 bits are network ID, and the remaining 24 bits are host ID. Class B addresses start with 10. The network ID takes 16 bits, and the host ID 16 bits. Class C address starts with 3 bits, 110. The network ID is 24 bits long, and the host ID is 8 bits long. For Class A network, as the host ID is 24 bits, it can support 2 power 24 minus 2 hosts in such network. It is a very large network and difficult to manage. Subnet is an approach allows a network to be split into several parts for internal use, but still act like a single network to the outside world. It means these subnets appear as a single routing table entry. The question now is why we need a subnet. The first reason we have mentioned that a LAN may grow to be too large to be handled and must be split into subnets. The second reason is to allow different subnets to be connected within an organization. The diagram shows an example of subnets. In a university, different schools' networks are organized as subnets which are connected to the main router. The main router connects outside internet and internal subnet. The main router has a very important role for the entire university network. It takes charge of the communication with outside. Every outgoing packet is sent out through the main router. The main router also forwards packets from outside to the intranet. But the issue is how the main router knows the intranet structure. Using a table to record each host address and the next hop can be a solution, but it will result in a larger routing table. Or we can think of using a mechanism called subnet mask. Subnet mask. A mask is used by the router to determine which subnet the packet should travel to. Subnet masks can be specified in dotted decimal notation with the addition of a slash followed by the number of the bits in the network plus subnet part, such as 255.255.255.255 202.224 or 202.10.23.102/27. Routers will end the destination address with the subnet mask in order to get the address of the router where the packet should go. Using this method reduces the number of individual addresses that each router must store, resulting in smaller routing table. The address of subnet contains three parts: the network ID, subnet ID, and host ID. In this example, a class C address is given. The first 24 bits are network ID. Then we have 3 bits which are subnet field, and the remaining 5 bits are host field. How to do subnet? We use an example here to explain the steps of subnetting. Subnet is constructed via borrowing bits from the host part of an address. Subnet is constructed via borrowing bits from host part of an IP address. In this example, we borrow 2 bits from the host ID, but we need to exclude 00 and 11 combinations. Hence, we only have 2 subnets created, and each subnet can contain 2^6 minus 2 hosts, which is 62 hosts. Subnet cannot solve the problem of running out of IPv4 address. It will actually result in the loss of IP address space. Why? We explain it through an example. For a given C class IP 202.38.187.0, before we do subnetting, we can provide 256 IP addresses, among which 254 are valid IP. If we borrow 2 bits from the host part, so we can have 4 subnet ID, and only 2 subnets are valid. Each subnet can provide 62 valid IP, which has been explained previously. Totally, we have 2 by 62, that is 124 IP addresses. The question for this section is, given an IP address 202.38.197.0, try to create subnet for a school with at least 4 subnets with 20 pieces for each subnet. That's it for this section. Thank you.